Okay, hi everyone. So if you see your name next to this number, okay, can you please send me your graph in the group? Okay, so Wang Songhan, Stephanie, you send the graph for number 3. Doesn't matter whether you have finished question C. I know that question C is a problem for some, but just make sure I can see this. I want to see the table. I want to see the, you know what, I should write this down, right? I want to see the table. I want to see the graph. I want to see the equation of the straight line. Okay, as long as I can see that, then that's good enough. You don't have to send in the answer for C if you can't. Okay, Ng Wei Zhen, question number 2. Send it into the group now, please. David, Ng Wei Zhen, number 2. Wong Chong Han, Stephanie, number 3. And then Simbury, number 4. Okay, I only want to see, yeah, I really should write this down. Otherwise, I'm going to, what is this? I want to see the table. Okay, I want to see the graph. Okay, and I want to see the equation or straight line. Equation means you have to show me the gradient and you have to show me the C lah. Okay, so all right, let's take a look at question number 2 first lah. Okay, question number 2 is David's question. Okay, so this is David's, this one. This is his okay, so David, can you explain to us, okay, maybe you unmute yourself and explain to us what is this about? Actually, it's correct, but I just want to ask you, what is this about? Why did you do this?
That one is for the C.
The one is for the C.
Yeah.
Oh, okay.
Forget to write.
All right, okay. So the good thing is this okay, I like the fact that what David did was that he changed the non-linear. This is the original equation, kan? Right, David?
Yes.
So this is the equation in the question. And then he changed the equation to follow the graph because the graph is 1 astaga. Okay, the graph is 1 over y against 1 over x. Oh dear. Okay, 1 over y against 1 over x. And you can see his table over there. Okay, so if you see, you look at David's table, I like the fact that David's table, everything is 2 decimal place. Okay, and this is again, saya punya nasihat untuk kamu is in the table, make sure it's 2 decimal place. Then only in the graph, you see if you can put the 2 decimal place in. If you cannot, then only you round off. Then only you 精微 lah. Okay, so don't round off at the table. You round off in the graph. So I like this 0.66 instead of 0.7. Because I noticed that some of you, you put 0.7 because you round off in the table. Don't do that. Because when you plot, actually you find that you can plot 0.66 in the graph. And it's a much better graph than 0.7. Okay. Just one thing, David, I would suggest that, okay, so when you find the y-intercept, right, okay, always put a mark over here and then tell me what is the value. What is this value, David?
3.7.
Okay, it looks at 3.7. So you mark here and you put 3.7 like that. Okay, on your answer sheet. Okay, so the rest of you also do the same. When you have a y-intercept, mark it and then write the value there. So you don't forget. Okay, this 3.7 is the C. Okay, you must write down so you don't forget. Okay, secondly, and this is something that is new that I want to introduce to you, especially because you are not science students. So science stream students will know this. Okay, when you count the gradient, so David, you use this dot and this dot. Is that true?
Yeah.
Okay. So when you count the gradient, actually when you count the gradient, you should try to use the as far away dots as you can. Okay, so I would actually take this dot, okay, David, I would actually use this and I would maybe use, okay, I can use this and this. Okay, and this is far away enough. Okay, the further your points are where you do the gradient, right, the better your gradient will be. Okay, I'm not gonna lie, it's true. Okay, you should choose far away points that are further away when you calculate your gradient. Okay, is that clear, David? Do you understand? Everybody else can, huh?
Okay.
Okay, so next time lah. Okay, because we're doing exercises, so this is where we learn from our mistakes. But a few things that you should take note of lah. Okay, and I'm telling you this now only because we want to take it slow and learn, and add more new things as we go. If I teach everything in the beginning, maybe you forgot already. Okay, so these are things. I'm not saying that your gradient is wrong. Your gradient is probably correct, but sometimes there's a small different value lah. Okay, like for example, your gradient here is -5. How do you count your gradient -5? You didn't show me the calculation, huh?
At the graph.
Oh, okay. I saw. Okay. So, if you see down here, okay, sorry, okay, if you see down here where David wrote, okay, he shows how he calculated his graph. So he got -5, okay, which is a good value. Okay, I'm not saying that it's wrong, but again, next time we follow this principle, we use as far away points as possible to calculate the graph. Okay, so this is good now. I like the fact that David saw that this is the gradient and the gradient is equals to -5. So he write like this. Okay, and then after that, this 2 over h is the c, which is the y-intercept. So he can calculate h from here. So actually, you already answered the question, question C, right? Which is find the value of h and k. Okay, so this is a very classic example, very classic question, okay, of using the graph to find the value of h and k. Okay, which if you do a lot of practice, actually it becomes very easy one, very, very easy. When you will notice that, always the letter got something to do with the gradient and something to do with the y-intercept. Okay, for sure one. Okay, for sure they got something to do one. Okay, that's why I said, when you do this question, when you do a linear law question, you just follow all the steps. Do the table, draw the graph, draw the best fit graph lah, okay? And then after that, find the gradient, find the y-intercept, form the equation. Okay, form this equation. So actually, I can say that this is 1 over y equals to -5 1 over x plus 3.7. This is the equation of the straight line. Okay, so job well done. Okay, very, very good. I like this. Everybody else who is doing number 2, you can refer to David's one as a reference lah. Let's see who comes up first. This is Wei Zhen, the same one, number 2. Okay. Oh, very nice. Oh, okay. Very nice. Very nicely done. Wei Zhen, which points do you use? Okay. Now, okay. Okay, Wei Zhen, same thing. Do you notice that your graph is hanging in the air? What did I say about the graph? The graph must go all the way until it touches the y-axis. So you have to extend this. Must. This side go to the x-axis, I don't care. But I must touch the y-intercept. Okay, because our equation, y-axis equals to m x-axis plus y-intercept. So I must see the y-intercept in your graph. Okay, I must see it. If I don't see it now, then your graph is hanging in the air already. Okay, so but the good thing is your gradient is very nicely counted. Okay, you use very far away points. Okay, so very cantik. 这个 definitely cannot. You know why? What does the question say? The question say use the graph, not calculate the C. Okay, this is use calculation. Kalau soalan dia cakap use calculation, then you can calculate. Tapi this one you use calculation, right? You substitute the x and y and the m, then you calculate the C. Cannot. Okay, because the question is very specific. Question 讲 use the graph, so you must use the graph. Okay, Wilson? All right. So this is well done. Okay, you used this one, and then of course you substituted the gradient lah. Okay, so this is again this is the only problem there. Okay, but don't worry, we learn from our mistake over here lah. Don't have to send again Okay, Rachel, don't have to send again, but just remember where you make the mistake. Okay, put your correction inside your own paper, but you don't have to send it to me. As long as you know what you're doing lah. Okay, sorry, question number 3, right? Okay, Stephanie's one. Let's do Stephanie's one now. Okay, question number 3. Stephanie, did you manage to do the C question? Did you manage to find the value of whatever the value is? Let's talk about Stephanie's graph first. So Stephanie's graph looks very nice. Okay, if you take a look at the points that she put in the jadwal, okay, she already put it into 2 decimal places. But actually, when you plot, the 2 decimal places cannot be seen lah. So maybe it's just 14.7, 16.6 also can. But remember, in the table, you only round off to 2 decimal place. In the graph, only you try to do the best that you can. Okay. Again, the same thing as I told David just now, Stephanie. Okay, the same thing. When you have a y-intercept here, you mark it. Okay, can you tell me how much is the y-intercept? 14. Okay, so again, you mark the same thing, 14 over here. Okay, and then, okay, so very well done. She did the 14. Which points did you use for the gradient? 19.7 是第三个。1, 2, 3. Here is 19.7. Oh, 9 and 19.7. So this one, right? And the other one is 14.65. 14.65 and 1, which is the first one. Okay. So again, same advice as I gave David just now. Try to use the further away points. Okay. But, okay. And this is the one that I want to mention now. When you use the points on the graph, okay, actually, if you take a look at the point in the graph, okay, this is not really 19.77, right? And actually, is about like this. It's over here. It's about 19.5 because you're using the graph. 19.77 is actually the value from the table. And I understand why you use the value from the table. Okay, but again, the question is saying what? Use the graph. So, in your graph, you had to change the 19.77 to this point, which is about which is about 19.5. Kan? So actually, I would have, what I would have done? I would have done this lah. Okay, hold on. So let me rub off everything. Okay. So since I'm going to do this, okay, I'm going to use this point. I would actually write down the coordinates according to the point that I see. Okay, so this is actually 9 and 19.5. Because on the graph, you already changed the value of the 19.77. That's why I would have changed the value also. Okay, again, this is new. Okay, and that's why I have to have a second class to talk about this. Okay, I know the first time I said just use the value on the table only. Okay, but now I want to teach you because the question keeps saying use the graph, use the graph, use the graph. So we want to use the graph. Same thing like this one. The first point that you use is 1 and 14.5. Okay, not 1 and 14.65 because that is the table value. What does the question say? Question say use the graph, not use the table. Okay, you understand what I'm saying? So when we say use the graph, means we have to read again the values on the graph. And sometimes it will be different from the values on the table. And that's okay. Okay, you have to understand that, let's say the real answer is linked and, 0.62 Let's say the real answer, the marking scheme punya answer is 0.62. It doesn't mean that your 0.64 is wrong. Okay? It doesn't mean that 0.64 is wrong because the exam, usually there is a certain range one that they will accept. So 0.62 means if your answer is between 0.60 to 0.65, most likely they will accept. Okay? Because, again, as I said, different people will draw different graph. Okay, lain orang dia akan draw graph yang berlainan. So the gradient will also change, but the change is very small It cannot be like 0.49. This one definitely tak boleh terima It's too far away from 0.62. But if the answer is 0.62, the 真的 answer is 0.62, there is always a range where they will accept. So don't have to worry. Okay, as long as you follow what the question asks. Question say, use the graph to determine your gradient. Use the graph, not use the table. Okay, so this is where we improve lah. Okay, this is where we improve on our work. All right. Again, Stephanie, did you manage to answer the C question? No. I just want to check whether you answered the C question. Y equals to 3ax plus b over 6x. b over 6x. Stephanie, no. Okay. So let's start with this lah. Okay. Y equals to 3ax plus b over 6x. And then our this one is xy against x squared bahkan. Okay, xy against x squared. That means this y we have to change to become xy. Okay, what do you think we should do to this equation in order to change to xy? Anybody? Come suggest. What should we change? What should we do to this one? Okay, multiply everything by x. Okay, so let's take a look at what happens when we times everything by x. Okay, we times everything by x. So y times x will be xy lah. 3ax times x will be 3ax squared plus b over 6x. b over 6x, if we times by x, will be 1减. So it will become b over 6. And do you notice now that this is my y-axis, this is my x-axis bahkan. Okay, so who can tell me my gradient is actually what and my c is actually what according to the equation? Which one is the gradient? Which one is the c? 3a or b over 6? 3a or b over 6? Okay, c is b over 6. Okay, and m is 3a. Okay, so can we find the value of the a and the b? Of course you can. When you find the value of the gradient and you find the value of the c, you substitute in, then you pindah, then you can find the value of a lah. Okay, all right, so give this a try. Let's use Stephanie's answer lah. Okay, so Stephanie's answer, let's go back to Stephanie's answer. Okay, so Stephanie, sorry. Okay, Stephanie, the gradient is 0.64. Okay, so we use 0.64 lah. So m equals to 3a. And we saw that just now lah. After we change m equals to 3a. M is 0.64 equals to 3a. And can we find the value? Can you tell me what's the value of a, please? Quickly, calculate for me. 2 or 3 decimal places is fine. Okay, 0.21. Gao tim. Okay, gao tim already. So that's why I keep saying find the gradient, find the c, find the gradient, find the c, then change this one. Because sure got something to do with this one. Okay, then the second one is b over 6 is equals to c. So I'm going to c is 14. Sorry, our c is 14. Okay, so I'm going to put 14 over here. Can I calculate the value of b? Very easy, right? Can. Okay, so what's the value of b? Really? Okay, it's 84. Okay, you saw 4. 14. Okay, 6 times 14 is 84. Okay, so Stephanie, Stephanie and all those who are doing number 3, your question number 3 got it already. Okay, you already found the value of a and b because always got something to do with the gradient and the y-intercept. It's just that we need to learn how to change, okay, the non-linear to become linear. Okay, that's why the axis is very important. Okay, all right, good job. Let's do this last one, question number 4. Okay, so I'm going to use Charlotte's answer since Priya's one is, there's a little mistake over there. Is it Charlotte? Okay, so Charlotte has a 1.2 over there, negative 1.2, and she has calculated the graph, the gradient of the graph using 19.93. But again, just to remind you, the same thing that I told David earlier, and everybody else also pay attention. When we calculate the gradient, we have to use the value in the graph. Okay, so you're using the link and part 0.8, which is this last point over here. Okay, but this one is, if you take a look, this is 14.7 only. You cannot do 14.77. Right? So this is 0.8 and 14.7. Okay, and what's the other one? 0.5. Okay, 0.5 is here. So this is 0.5 and this is about, oh, sorry, I shouldn't mark. Okay, 0.5 and this is about 8.7. 0.5 and 8.7. Okay, because again, now we use the graph. We don't use the values from the table. Okay, but today with this one, sorry, 0.7, 8.7. Yeah. That's why we don't need to have this 8.74 and this 14.72, because on the graph, I cannot see 0.72. On the graph, I cannot see 8.74. I can only see 8.7. Okay, so this is where we learn and we improve from there. Okay, 19.93, and she has already changed this one, okay, to y squared over x to follow our this one, and 1 over x to follow our this one. 19.93 and negative 1.2. Okay, let's look at the question again. Question say, okay, so this question is a bit different. It says find the value of y when x is 3.6. Okay, now if you look at this one, our graph is not x and y anymore. No? It's 1 over x and y squared over x. Okay, so we have to do a little bit of calculation. Okay, I'm going to use this. So when x is 3.6, okay, when x is 3.6, 1 over x is how much? Can somebody quickly count this for me? 1 over 3.6, how much? Okay, 0.28. Okay, so we start with 0.28. Okay, 0.28 on the 1 over x-axis. So 0.28 is 1, 2, 3, 4, 5, 6, 7, 8 lah here. Okay, and then what we do is we draw a dotted line towards the graph. Okay, and then after that, when we hit the graph here, we go to this side. We go towards the y-axis. Okay, what is this value? This value is about 4.4. Okay, the value is about 4.4 lah. So when 1 over x is 0.28, we get the value of 4.4 on the y-axis. Okay, y-axis is equals to 4.4. But actually, what is our y-axis? Our y-axis is y squared over x, bahkan. So y squared over x equals to 4.4. Can I find the value of y? Of course I can, because I already have the value of x. And so y squared over 3.6 equals to 4.4. I bring the 3.6 up. Y squared equals to 4.4 times 3.6. Okay, I'll get 15.84. But the question asks for y. And so y equals to square root of 15.84, which will give us 3.98. Okay, 3.98. This is my final answer. So this one is a little bit different from question 2 and question 3. Okay, this one, so this one, that's why I want to discuss with you. Sometimes the question, they will not ask, they ask you to find other values of y and x. So you have to use this dot, 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 dot. Okay, but again, everybody, let me remind you, different graph will have slightly different answer. So maybe for some of you, maybe Sinbury, you got 3.96. Maybe Freya, you will get, 3.99. It's okay. Okay, it's a very small difference. As long as it's not 2 point something, that's too much of a difference. Yeah. Okay, so kita tidak mau sampai situasi begitu. Okay? Alright. So, yeah. Okay, I'm going to send this into the group so that whoever wants to refer can refer to this. Okay, but I'm going to use the same drawing again from Freya. Sorry, from Charlotte. Okay, but we're going to answer the second question. The second question is express y in terms of x. Now we have seen this question before, right? Okay, how do you express y? First, you have to write the equation. Oh, sorry. Okay, so equation has already been written, okay, by Charlotte. Charlotte has already written the equation. She already find the gradient. She already find the y-intercept. So now we want to change this. Okay, we want to change to become y equals to 这样子, okay, like that. Okay, what do you think we should do first? I want to change this y squared over x become y. What is the first step? Is okay, move the x to the right side. So you multiply everything by x. So you will get y squared equals to 19.93. 1 over x times x will be yet enough. Okay, you minus 1.2x. Okay, but we're not done. I want y, I don't want y squared. So one more step. What is my last step? So y, if y squared becomes square root, become y. Okay, and then this whole thing will be 19.93 minus 1.2x. Done. Because what does the question say? Express y in terms of x. Okay, no need to continue already after this. Stop. Okay, you can do this one. Can one. Okay, just pindah until you get y. Okay, so again, let me remind all of you that this answer and this number may be different for different people. Okay, but it will not run away very far lah. Dia tidak terlalu jauh lah. Okay, maybe 19.95, 19.99, that one can lah. Okay, but not like, 21, that one tak boleh. Itu terlalu jauh sudah. Okay, that's too far. Okay, so again, I'm going to send this so that you all can refer to, especially how to answer number 4 lah. So if you notice that there are two types of questions, okay, for linear graph. Sometimes they ask you to change the equation, like question number 2 and number 3, right? They ask you to change the equation and then use the gradient and the y-intercept to find the value of h and k. Sometimes they will ask you to find other values of y, and then we use that dot that one lah. Okay, and then after that they ask you to express y in terms of x. So we have to be used to all these kind of questions lah. So what you can do is you can do page 168, question number 2. Okay, the one on top, okay, in your textbook. If you want also page 169, question number 5. Okay, and if you want to have some more practice, obviously, okay, page 172, question number 10. Oh, no, question number 9, and page 173, question number 11. Okay, if you want to practice from the textbook, the textbook got all these kind of questions. But for next week, make sure that you have enough graph paper.